Hello everyone, myself Junaid Ahmed Chaudhary, and let's start the next lecture, which is our second lecture of the subject. And in this lecture, we will be basically discussing about what makes a structure and the principles of stability, and also we will discuss the different types of forces. Also, we will discuss the equations of equilibrium. We will discuss the various loads, and also finally we will discuss the different properties of materials. That means we will discuss the malleability or ductility. Okay, so let us start the lecture. So this is the introduction part of this lecture. So within the context of the built environment, the term structure refers to anything that is constructed or built from different interrelated parts with a fixed location on the ground. The structure is responsible for maintaining the shape and form under the influence of subjective forces. Okay, so next is the force. So it is important that the strength and stability of a structure and its individual components must be considered. Structure analysis is used to calculate the effects of the forces acting on any component and on the structure overall. Okay? So the structure means that is constructed or built from different interrelated parts with a fixed location on the ground. That means a structure must be located on a fixed part or fixed location on the ground, and it will have the different components. Say if you consider a building, it will have different components like beams, columns, footings, slabs, staircase. If you are considering a multi-storied building, then it will have stairs. Or if you consider an Assam type building, then it will have roof. That means your roof might be your king post truss or queen post truss. Okay, so it will have. So if you are similarly, if you consider a bridge, it will have different components like deck, then railing, then girders, then piers, then span, then width of the bridge. Okay, so everything you have to see. Okay, so next for the strength and stability of a structure, and we have to consider the different forces or different loads which will be acting on it. Okay, and structural analysis will be used to calculate the effects of these forces on any component and as a whole on the structure. Okay? So in this, I think you have got the idea that structural analysis deals with the various forces which will be affecting the different components of a structure and as a whole, the different forces which are acting on a particular structure. We can find out those values of those forces or loads or by different methods in structural analysis. Okay. So three properties of forces that must be considered, and they are magnitude. That magnitude means the size of the force. That means how much force is acting on a particular structure. We have to consider that. Then the direction in which the force is acting. That means it is a very important component of force. So we must consider the direction in which a load is acting. That means it might be your horizontal, it might be your vertical. So if for say example of horizontal force is your wind load, earthquake load, and example of your vertical directional force is your live load, dead load, imposed load, etc. Okay, and next we have to also consider about the position of the force. That means at which position the force is acting. Okay, so these are the main three properties of forces which we must consider while designing or planning a structure. Okay, and they are magnitude, direction, and position. Okay, so next, Sir Isaac Newton developed three laws of motion, and I hope all of you have already studied those three laws: the first law, second law, and third law. Okay, so I won't go in details about these three laws because you have already studied in physics, and here we will study only the application of these forces, of these laws, but we will not study in details about these laws again because you have already gone through in details about these three laws in physics. Okay, so let us move to the next part of our lecture.